So here we will see about logarithmic function. So before we start this, let us recall about the exponential function fx is equal to b to the power x, where b is greater than 1, and let this be equal to a. This b to the power x part, if we assume it as a, this part, when we reverse the order of the exponential function, and we can write that in this form in reverse order, that let b be greater than 1, be any real number, then we say logarithm of a to the base b is x. Logarithm of a to the base b is x. Logarithm of a to the base b is x. So here what we are getting the value of the exponent by the use of logarithmic concept. By the concept of logarithm, we are getting the value of this exponent part here. So this is what we are this is what makes logarithmic function very, very interesting. So now let us first talk about the definition part of logarithmic function. So logarithmic function is defined as log with base b from positive real number to real number. Now why we say positive real number to real number? Because here in this case, whatever you will replace here, a part, you have learned that in exponential function that fx, which we have assumed as a, will always be a positive real number, and in logarithmic function whatever you will place here will always be a positive real number. So we say that log to the base b is a function from positive real number to real number. Why to a real number? Because the result which you are getting here, this exponent part, in exponential function you have learned that this exponent is always a positive, can be a positive real number. So therefore we say that log to the base b is a function from positive real number to real number, because here we will always have positive real number, and here the result which we are getting, the exponent part, can be any real number. So log to the base b, logarithmic function is defined as log to the base b from is a function from positive real number to a real number, given by log x to the base b is equal to y. Given by log x to the base b is equal to y. Now this log x to the base b is equal to y is for what? Is for b to the power y is equal to x. Is for this form of exponential form. So you can clearly see that when we talk about logarithmic function, we get the exponent part as the result. So you can have so many examples to understand this part. So I have taken here two examples. Look, this is an example of exponential function. E to the power 0 is equal to 1, 10 to the power 2 is equal to 100. These are examples of exponential function. If you remember, this is called natural exponential function, and this one is called common exponential function, because here the base is 10 and here the base is e part. This same thing can be written in the form of log as log 1 to the base b is equal to 0. So the base part of the exponential form, exponential function is also the base of log here. When we convert exponential to logarithmic form, the base part of the exponential will be the base part of log, and the result part, the value of the exponential function e to the power 0, that is 1, here I have taken it as domain part of the logarithmic function. Then the value of y for the logarithmic function is the exponent of the exponential function. Here also, when 10 to the power 2 is equal to 100, then log 100 to the base 10, so base will remain the same, is equal to the result. Result is what? The result is the exponent part. So this is how we convert the exponential to logarithmic form as per the definition of logarithmic function. So these kind of functions are called natural logarithmic function, and these kind of functions are called common logarithmic function. Log 100 to the power base 10 is 2, log 1000 to the base 10 will be 3. Why? Because 10 to the power 3 is 1000. 10 to the power 3 is 1000. So in this way, we convert the exponential to logarithmic function form. So therefore I told you that this is a very, very interesting one. A logarithmic function is very, very interesting one, and you must go through this properly. Now, when we talk about this part, natural logarithm, we denote it by ln, natural logarithm. So in your textbook you will find questions which are from this part, natural logarithm part. So everywhere you will find log x written. So what does it mean? It means that we are talking about log x to the base e, which is hidden there. So you have to take it granted for questions of your textbook that if no base is there, the base part is e. That means we are focusing on natural logarithmic functions. We are focusing on natural logarithmic functions. So like I have given you some silent features for exponential function. Here are some silent features for logarithmic function. Some silent features of logarithmic functions are the domain of the function is r plus, that I have already explained here, that it is from r plus to r and the range part is r. So in logarithmic function the domain cannot be a negative real value or even 0. The domain should always be a positive real value. And the range part is or can be any real value. The value of y can be any real value in case of logarithmic function. You can see the graph which I have plotted here. The value of the x part, here is the x-axis. I have not gone to the negative direction of x-axis. This is the negative direction of x-axis. All the values are to the positive side of x-axis. So we can take any real values of x. And the value of y, if you see this y-axis, the value of y is from minus infinity and it rises and it will go on and on. So from that is the range of f part is r. 1, 0 will always be a point on its graph. In logarithmic function, like in this case, you see log, when you take log 1 to the base e, the result is 0. The result is 0. Similarly, if you see 10 to the power 0, this is 1. So when you take log 1 to the base 10, again you will get 0. So if you write 20 to the power 0, that will be equal to 1. So here also if you use log 1 to the base 20, so this will be again equal to 0. So whenever you take the x part as 1, no matter what is the base, you will always get the value of y as 0. Whenever you take x as 1, whatever is the base is, whether it is base is e or the base is 10 or any other real value, so in all the cases you will get the value of y as 0. So therefore the graph will always pass through 1, 0 for logarithmic function. So that is what I have written over here, that 1, 0 will always be a point on the graph. It is an ever increasing function. It is an ever increasing function. That means if you go through this, it always increases as you move with the value of x. As the value of x increases, the value of y also increases. So it's again a ever increasing function. This is common between exponential function and logarithmic function. Both are ever increasing functions. Here in this case, when x approaches 0, so x approaches 0 means he is this side. So for x approaches 0, fx approaches minus infinity. The value of the y part approaches minus infinity. That means it will be in the fourth quadrant. It will almost touch y-axis. It will never meet y-axis. Remember, when x approaches 0, fx approaches minus infinity. It will not meet the y-axis, but it will almost be touching the y-axis in the fourth quadrant when x is approaching 0, when x is very close to 0. In such case it will happen. So these are some silent features of logarithmic function. Now one more interesting thing, when you compare the graph of logarithmic function and the exponential function, then you can see that the two graphs are mirror image of each other. They are the mirror image for each other for the line y is equal to x. See here, if I draw a line, graph of a line y is equal to x, this is for y is equal to x. So the graph for y is equal to x will be of this nature. And this you have learned regarding the, if I say this point is 1, 0 and this point is 0, 1. So you have learned that the graph, just now you have learned that the graph for logarithmic function is something like that. This. and the graph for exponential function is like this. So you can see that these two graphs, this is for fx is equal to log x. We will now be talking about natural logarithmic function and natural exponential function. So it is to the base e, and this is for fx is equal to e to the power x. Don't get confused. If we take any kind of exponential function, we will get the same graph. If we take any kind of logarithmic function, whether natural or common or an ordinary logarithmic function, in all cases the graph will not change. The nature of the graph will remain the same. So in these two cases, what we are finding that they are mirror image of each other, provided that we consider y is equal to x as the line, mirror line. So these are some very important points to keep in your mind before you go through some properties of logarithmic functions. And the properties are log AB is equal to log A plus log B. Log A by B is equal to log A minus log B. Log A to the power x is equal to x log A. Obviously just now you have learned that log 1 is equal to 0. Here in all the cases we are talking about base E. In case you find that the base is different from E, there it will be mentioned to you that the base part is different. So I hope this is clear to you all now.